Well, good morning, good afternoon, good evening to everyone, wherever you may be across the world. Thanks so much for joining us here live today for Serverless Office Hours. And we're streaming on the AWS Twitch channel and Serverless Land YouTube channel and Serverless Land LinkedIn channel as well. So thank you wherever you're joining us from. My name is Julian Wood. I'm a senior developer advocate for Serverless at AWS. And I'm super duper happy to be able to welcome today Lia Vader. And Lia is a senior solutions architect as part of the developer acceleration team. And I know that's sometimes a mouthful, but I think the developer acceleration team is an awesome team because they're out there to help you, big companies and small, to accelerate their journey with AWS. How are you, Lia, today?
I'm good. So
cool. So you've been at AWS, what was it, 7.5 years? Or have I already? I know you're a big dog fan, so in dog years that must be like, I don't know, about 100 kind of thing. But yeah, what have you done at AWS? Has it been AWS the whole time or Amazon? What's excited you about your journey so far?
Yeah, so I've been with AWS for 7.5 years, almost all of that in solutions architecture. And yeah, I actually predate Lambda by just a little bit. So I've got to see cool. I got to see like serverless applications from like before they existed to like where they are today. So that's been really fun and interesting. Cool. And I've had a lot of different like solutions architect roles over the years. I was a serverless specialist for a while. Right now I'm doing developer acceleration, but I used to work directly with enterprise customers, and before that just with startups. So kind of the whole, all across the board, from the very beginning when like everybody ran everything on EC2 to today where like almost all my customers are running completely cloud native.
Oh, cool. So that is fantastic to hear. So, I mean, to see that journey from sort of EC2 all the way through Lambda and being cloud native, I mean, is that cloud native? What does that mean in your mind, or in your mind and also your customer's mind? What do they mean when they're saying cloud native?
Yeah. So that's a good question, because that can be a little bit of a marketing term, and it kind of means something different to everybody. Like if you ask some companies, that means Kubernetes. But for AWS, it means a lot more than just containers. It means that we're actually like fully utilizing the cloud and we're not doing undifferentiated heavy lifting. So this means like some serverless, this means containers, and means like utilizing like the right databases for our use case, whether it be DynamoDB or TimeStream or like Aurora.
Cool. Excellent. Well, Lia is a proper expert on security, and she's going to be talking all about security. But what we're going to do just first is just look back over the past week of AWS serverless and see what's been happening. Well, last week on the show was a really good one. Good old Eric Johnson spoke to Dan and Daniel, talking all about TypeScript and SAM. So if you are using TypeScript in your Lambda functions, this makes it much easier to be able to deploy your Lambda functions with SAM. Yeah, a whole bunch of releases that came out over the past week. Lambda's got a few, but first up, EventBridge. That's a really cool way that they've actually changed the management console. So they've got better rule filtering and event transformation capabilities. So if you are an EventBridge user, and if you're not, you should really be looking into it. EventBridge is awesome. Some cool new stuff in the management console. Then the Lambda team and ancillary teams have been busy as well. We've got the DevOps Guru is extending support for Lambda with its Code Guru profiler integration, and we are actually hoping to have someone from the DevOps Guru team on the show in a few weeks' time to be able to talk about this. And this is sort of using machine learning to get some clever insights into your code. Talking about security with Lia as well, Lambda has announced support for principal org ID in resource-based policies. So this is a way that you can, if you're using AWS organizations, you can lock down or permit Lambda functions for a whole bunch of different things based on the principal org ID, which gives you a lot of flexibility. Also within the console for Lambda this time, you can now share test events between developers. So previously, you could create your test events but you couldn't share them, and that was annoying and painful. And so this is a really simple way that within an account you can share those test events, and that's really cool. And then obviously, if you're using DynamoDB, everything's going to be big and huge. So DynamoDB has actually increased the default service quotas to simplify the use of large numbers of tables. So hopefully that's going to be useful for you. A whole bunch of blog posts on the Compute blog, which have come out recently as well. something to do with EventBridge and sending events from AWS Organizations account, from Elanisa and Iris. Also cool stuff with step functions and API Gateway and running cross-account workflows from Hardik and Pratik. And then, if you're a Java developer and you're wanting to do mutual TLS, Dheeraj and Christian have done a comprehensive blog on how you can set that all up with various certificates. Then Rahul and Dheeraj also have talked about the principal IDs, so that's worth it if you're looking from a security perspectives. If you're into APIs and doing WebSockets and you want to go multi-region, of course you want to do serverless. So Ben and Marcus have you covered with a blog post for that. And then also if you using step functions, which is just awesome for connecting anything synchronous or asynchronous services. And this is a really cool blog post on composing step functions to abstract the polling of asynchronous services from Nicholas and Gutzel and Shukrat. So yeah, lots of AWS compute blog posts that have been coming out over the past week. Now, if you are into serverless and you're on Serverless Office Hours, so we hope you are, this book is now on its second edition, and Peter Sparsky, Jan Trey, and Ajay Nair, who's literally one of the godfathers of Lambda, have released this book, and this has really got some great tips and tricks from the beginning of understanding the importance and what serverless is, all the way through to showing you how you can implement it. So that's looking out back over the past week. We're going to be talking about more specifically serverless security, but please send us any questions you may have. Tell us where you're listening from. Please like us on and subscribe to us on the YouTube channel so you can get notifications when we are coming up. So we do have Zach Jones Noel, who says already that he loves the shareable events on Lambda functions. Thanks, Zach Jones Noel. Appreciate that. But yeah, send us any of your questions. We'll either do it during the show or at various kind of sections, but send them on whether they are about security or general serverless development. So Lia, tell us about serverless security and some best practices.
Awesome. Okay, so let me start. I'm going to share my screen.
Yes, certainly. We'll swap it over.
Okay, so you should be able to see my IDE and my console. We'll get to that in just a second. I'm going to show some really quick slides just because I want to lay some groundwork and introduce what we're going to talk about. Then we're going to go in. We're going to take this simple API I have called Dog Finder. I'll explain that in a bit. And then we're going to take this very unsecure API and make it just a little bit more secure. So let me pull up my slides really quick. Okay, so like I said, I'm going to talk really quick about what we mean by serverless security, how to think about it, and then we're going to apply some of these best practices to our use case, which is Dog Finder. But first and foremost is we need to make sure we understand the shared responsibility model. So you may have seen this before, but just in case. It outlines what AWS is responsible for versus what you, the developer, are responsible for. So simply put, this just means that AWS is responsible for the security of the cloud, while you're responsible for the security in the cloud, so what you deploy in the cloud. However, this diagram is a little more specific to serverless applications. So you're going to notice there's a larger portion of the diagram that AWS assumes. And this is really like one of the primary benefits of serverless. Doesn't mean security is free. Like as shown, like you can see that you're still responsible for securing your data, managing your application, internet access, permissions, monitoring, etc. So let's really quickly talk about how we model this out.
So Lia, just to jump in there, if we say that serverless is taking over more of the responsibility, that doesn't mean security goes away. It just means AWS handles a lot more of the security for you, like the operating system and network configuration, and all that patching. So you don't have to worry about it. We're doing it on your behalf, and then you get more time to concentrate on your actual applications and the security of your applications.
Absolutely, yeah. So cool. Like the platform, like your code encryption, so where you store your code that's encrypted at rest and so on, AWS is assuming all that responsibility with like Lambda as an example.
Okay, I don't mean to just distract you too much, but with all the sort of customers you talk to, what's their sort of biggest maybe misconception about security and that sort of shared responsibility model when it comes to serverless?
Yeah, I would say like maybe not necessarily the biggest misconception, but I would say like the biggest struggle is understanding how to handle authentication, authorization in serverless applications. Because I think most customers, when you come from it from like a traditional approach, are used to managing all of that end to end, and they don't quite understand what part they need to manage versus what part AWS can actually take for them. Especially when you move to like an IAM style of doing auth with your APIs, that can also, it's just like a different mindset, if that makes sense.
Okay, thanks.
So yeah, like I said before, it's like you can take a traditional approach to this, but we just saw with this here, this isn't a traditional approach, so we need to think about it a little bit differently. So there's a couple different models to look at that are out there. And then I'm gonna have a more simplified approach that we'll step through. So here I have the OWASP Serverless Top 10. You may have heard of this. OWASP Top 10 is like your de facto guide to understanding like the most common application attacks. So OWASP takes risks and they select them and prioritize them. And then they created the OWASP Serverless Top 10. And this project gives the same insight into serverless applications. So this is like a few years old now. And it covers risks like injection, broken authentication and access control, sensitive data exposure. So you can go to that link below. I have a tiny URL
Yeah, I've
for
posted.
you.
Yeah, I've posted that in the chat, so people can hopefully link off it.
Awesome. Yeah, so you can go to that if you want to read more. I'm not going to step through each of these because ultimately we're going to cover a lot of these today. Now, the other model to think about, if you haven't heard of well-architected, is the well-architected security pillar. And if you haven't heard of well-architected, please make sure you go look it up. We have links to the security pillar and then one also for specific to serverless there. And within the security pillar, we have 7 design principles. So you're already going to notice if you're reading through this and then looking at the previous slide, there's some overlap there. For example, like we have broken authentication and broken access control, and that corresponds to implementing a strong identity foundation. So again, we're not going to step through every single one of these because I want to like dive into our application a little bit. But looking at these different models that we have out there and looking at all the overlap, there's really 4 key areas that we can condense this down into. So we're going to take these principles, break them to the 4 categories, and apply them to our use case, which is an external facing API called Dog Finder. So first, we're going to talk about authentication, authorization. And I'll actually probably spend most of my time there. We're going to actually implement that on this API. And the reason why I'm going to spend a little bit more time on there is just because I get so many questions from customers on this. Next, we'll talk about like data encryption and integrity, and we'll look at the data flow and identify where you can encrypt data and what should be considered to preserve the integrity of that data. Then we're going to ensure that we have sufficient logging and monitoring through our architecture, and we're going to talk about what native logging features you should actually be implementing. And then lastly, for external facing services, we need to think about the risk of denial of service. And while serverless services scale quite well, you still want to think about how to protect your backend services and avoid any unnecessary invocations of your Lambda functions. And then for the internal facing services, you want to think about how to protect them from external sources. So let me introduce you our use case, and then we'll dive into how to protect that. So we have Dog Finder. So I like dogs. And Amazon has this dog culture. Like we let dogs in the office. I also sometimes bring my dog in the office, although not today because would probably be in my lap by now, and she's like a 90-pound Rottweiler. So,
and I don't think she quite knows what streaming is on the Twitch channel. So
no,
well, maybe she'd be really good. That'd be cool.
But anyway, the idea behind this API, and it's a really silly, simple API. The whole point is that we're going to add some security to it, but it's just for dogs. It's so that I can go out and find all the dogs. So the idea is like you register your dog, you tell me where your dog is located, what Amazon building, what floor, what your dog's favorite treats are. And then once I have that, I know, well, I can effectively stalk your dog and then like show up, pet your dog, say hi to you. This is only for dogs. I hope we don't have cat people online.
Well, you could redo it for cats, I suppose. But I suppose this is the initial one, and I suppose we're going to see the announcement at reInvent for this year for AWS Dog Finder, and then Cat Finder is the follow-on, maybe in a few years' time.
Yeah, we'll put that in as a future request.
Okay, yeah.
Okay, so like I said, this is a super simple API. It's API gateway. I have a few Lambda functions. We're writing to DynamoDB. So the data flow is very straightforward. First thing, we need to implement auth. So let's talk about what we need to consider. So when we're considering authentication and authorization, we need to ensure that we use the right mechanism for a use case for each component in our application. We also need to implement the principle of least privilege and take advantage of the fact that Lambda allows us to break up our code base into single purpose functions. And therefore, we can implement fine-grained policies for each of those functions. And then lastly, like our functions probably need access to secrets, API keys, etc., and those need to be stored securely. So this applies to those models that I was talking about before. That would be OAuth serverless top 10, broken authentication, and broken access control. And on the well-architected side, this applies to implementing a strong identity foundation and applying security at all layers. So first and foremost, Dog Finder isn't super secure right now. We have no auth on this. So we need to implement an API Gateway Authorizer. So you have a few different options here. API Gateway has multiple mechanisms to manage access to your API. So it provides fine-grained authorization as granular as authorizing decisions per caller at the combination of per path or per method level. So you have a few options, and I'll step through those. And then I'll step through, because it's one thing to understand what your options are, but it's another thing to understand when and why you use it. So I'll step through what they are, and then I'll go through which one you would use when, at least at a high level. So the first two are Cognito user pools and JWT authorizers. And these can validate any standard OpenID Connect, so OIDC, or OAuth 2.0 tokens. And so with Cognito user pools, it's using Cognito user tokens. And with the JWT authorizer, this is specifically for HTTP APIs. And the great thing about these is that there's no code that you need to write. So if you simply need to validate the tokens and authorize, these are two good options for you. And so you're validating things like the issuer, your client ID, the timestamp, the signature, and authorization scopes when specified. The next one is IAM-based authorization. So this provides you with the ability to enable like your service to authorize requests the same way that all AWS APIs do. So if you call like the Lambda API or the EC2 API, this is the same manner using SigV4 signing. So the client will need AWS credentials. And so if it already has them, that's very convenient. And as you know, when you have AWS credentials, there's a policy that's tied to that, giving them permissions to whatever resource. And in this case, it would be to your API, and you can get very fine-grained access control with that. And the last one, which we're going to actually implement today, is Lambda authorizers. So this is our most flexible and most common authorizer. So it allows you, when a request comes into API Gateway, to trigger a Lambda function, perform validation, like using your own custom business logic. And then your Lambda function is going to return an IAM policy and also cache that policy. API Gateway will cache that policy for further requests. So at a high level, that's how that works. But remember, the best practice is to find the right mechanism. So let's talk about when we use what. So we have Cognito user pools, and you have the user pool authorizer. And you're going to use that if you're already using Cognito user pools. So Cognito is your identity provider. That makes sense. If you're using API gateways, HTTP APIs, you have the option of using that native JWT authorizer. So that's a good option if you need to allow or deny a request based off of like token validations and scope of the token. And then we have IAM authorization. So that's a good option if your client can obtain or has IAM credentials. So most likely this is going to be a service within AWS. It could be another Lambda function. It could be your service running in a container or an EC2 instance. If you have IAM credentials, this is most likely what you want to do. This allows you to use SigV4 signing. So every request is individually authenticated. And when you call AWS APIs, this is the same SigV4 protocol. So you're managing your policies the same way you do in IAM. So this is generally what we recommend for like internal microservices or any like service-to-service calls.
So
Lastly,
just before the Lambda authorizer, I don't want to just jump in, but if it's possible to use IAM, would that just sort of be the preference above anything else? So if it is an internal microservice or anything that does have AWS credentials, start with IAM, and if you bump up against something there, then you need to look at the others.
yeah, that's generally what I suggest. One, like you have the fine-grained access control of IAM. Each individual request is signed and authenticated. When you have something like a JWT authorizer, or most likely you're using tokens in your Lambda authorizer, then like the token is generally good for about an hour. Like not each individual request is signed. So IAM would be my preference, but not everybody can do that. Maybe like in our case, Dog Finder is going to be a public API. It's unlikely that you on your cell phone will have AWS credentials. So in that case, you probably have some JWT token, like an identity token. And we may also have some like other custom authentication that we need to do. So this is where we want to use a custom authorizer or a Lambda authorizer. So this is available on both the REST and the HTTP APIs. So you can add your own custom business logic in your Lambda function, and then you can do your validation, you can make other calls, whatever business logic you need to add. And then you're going to generate an IAM policy, and that's going to get returned to API Gateway, which will then be evaluated. So we're going to use that. And before we go and implement it, I want to make sure you understand the flow. So let's step through that. So for our use case, we're using the Lambda authorizer. And first thing, I'm going to authenticate to my identity provider. For me, in the background, it doesn't ultimately matter what it is, but I'm using Cognito, Cognito user pools. So in the background, I'm just going to generate a token. It's going to be an identity token. Cognito is going to return that token to me. And then when I make a call to Dog Finder, I'm going to pass that token in the authorization header. So it'll be, we see that bearer space, I'm going to paste in my token, and it's going to get sent to API Gateway. First and foremost, API Gateway is going to check the cache. I'm not caching because it's a demo. And if it's not in the cache, then it invokes my Lambda authorizer. So at the bottom, and I'll show you this in a bit, we do have blueprints. So if you're wondering, like, where do I start with this Lambda authorizer? We actually have blueprints for you to work off of. So you just add in your business logic, and we have all the boilerplate code you need to generate the policy. So it's really, really easy. And you just need to add in your business logic, whether it be using a library to like decode your token and validate and so on. So we're going to validate the token in our Lambda authorizer. We're going to make any other call we need to. Some of my customers, they need to do lookups in Dynamo. Some customers need to make a call on-prem to do some validation, whatever it may be. And then our Lambda function is going to return a fine-grained IAM policy. So this is specific to the client, and we'll determine what paths and what methods that they have access to. We can also pass some context to our downstream Lambda functions as well. Or we can pass an API key that can be used for throttling as well. So API Gateway is going to validate that policy. against the request and either allow or deny the request. And if allowed, we invoke the Lambda function. And then we cache the policy according to your cache configuration for later requests. And we do that because there's no reason to keep invoking your Lambda authorizer if we already have the policy for your client. So in the console, this is what it looks like. We're going to create an authorizer. We're going to specify the Lambda function, and then whether it's a token or request authorizer, and then the header. I have CloudFormation, or SAM, but let's go ahead and just go ahead and implement it now. So as you can see, here's my dog finder API. It's really
Lia, would
simple.
you be able to just expand the window, just even make it onto the bigger screen, and then we could maybe see it
like this?
Ooh, yes, maybe zoom in a bit. There we go. There we go. Excellent. Okay. Thank you.
Okay. So, yeah, my API is very, very simple. It's /dogs. We can do a get and get all the dogs. You can do a put and create a new dog. And then we can specify, like when we actually do a put, we get a dog ID and we can specify that particular dog ID. Let me just show you really quick. So I'm just using Postman here. Can we see this okay?
Yeah, Postman doesn't easily look bigger, but I think we'll work it out.
Okay. Oh goodness, that really doesn't.
Yeah, that's cool. I think we will see that the request will go through well, or not.
Okay, so I should just first show you, I have no authorization on this. And if we look at the headers, there is no authorization header. So I'm just going to send this. And I'm going to get back. This is my dog. My dog's named Xena. She's named after the warrior princess. And here's my dog ID. So we saw here earlier, I can also specify by dog ID. All right, there we go. So let's go and add some authentication to an authorization to this API. Okay, so you can see code. So here's my SAM template here. I have multiple different functions. So this would be my get for all dogs. And then at the very bottom here, these are all my other functions. I have my REST API definition, and it's very simple right now. So step one, let's just add my authorizer function. It already exists. I pre-wrote it out, and it's right here. So I'm using the template, the blueprint that I showed you before, and that's actually what let me go pull that up for us so you guys can see. Okay, so we have a lot of blueprints already out on GitHub. And so here you can go pick your language of choice. And this is exactly what my authorizer is based off of. So I have a spot for my own custom business logic, and then I'm using all this boilerplate code below to generate my policy and then have API Gateway return a policy. So let me go back to my code now. So here I have a user pool. I need that, of course. So I have my I'm validating token here. Here's my handler. And then I'm generating my policy, returning the policy. But I don't actually have the Lambda function in my template yet, so I need to add that. So I'm going to copy and paste that because I've already pre-written it out. And I'll show you, and I'll walk through what I'm pasting. Okay. Okay, so this looks right. So here's my authorizer function. It is a serverless function. I'm pointing at my actual code here. I have some environment variables like for my user pool. I'm only allowing people who are part of the admin group to do like puts and deletes. So I have a admin group name that we're checking on. The other thing though that I'm adding here, and you'll notice I'm doing this for all my Lambda functions. While it's not required, it's a good practice or something to think about that when Lambda automatically logs to CloudWatch, as you're probably already aware, but it retains those logs indefinitely. So for each of these functions, I'm setting the CloudWatch group name or creating that log group. And then I'm also setting my own custom retention. And for this case, I'm using 7 days. So you need to determine for your organization and your application what's right. It may be 30 days, it may be 1 year, depending on the application. But keep that in mind, that's something you probably want to also do. So I'm doing that here. So now I just created, well, I haven't actually created it yet, but I added my authorizer function, but I need to go and add it to my API and also add it to also require the authorization header for each of my Lambda functions. So let me just start with my API. So I have the API definition right here. It's very simple. Scroll back over. So I'm just adding, you can see auth. I'm specifying my default authorizer, and then I'm creating that authorizer. So if you recall earlier, I had that screenshot in the console where we specify what Lambda function and all of that. That's what I'm doing here, just in infrastructure's code. So I have my token authorizer, because that's what we're using. I'm specifying my Lambda function that we created above or are creating above. The default is the authorization header, but I've specified that. This here is strictly for demo purposes. Reauthorize every is how often, how often we reauthorize or how long are we caching this policy for. I'm setting 0 because it doesn't make for an interesting demo if I cache, but the default is 300, which would be 5 minutes, which is fairly sane. Okay, so we created our Lambda function. We added auth to our API. But another good practice would be to require the authorization header for each of our paths. So let's go ahead and do that. And I'll show you what that looks like. So I'm going to scroll back up, hopefully not making anyone too sick doing this. I've looked over people's shoulder who are like scrolling madly before and felt a little ill sometimes. Okay, so here's my very first Lambda function here. So this is actually going to be under events, because remember, this is for requiring the authorization header. This is coming in through API Gateway. So for under the API, I'm going to add this for each of them. So I'm saying these request parameters, which is my header, and the authorization header is required. I don't need it for a cache key. We're not caching at API Gateway. So that is set to false. We'll get to the policy in a little bit. And then, of course, I already talked about how we do logging, and I want to set the retention period. So I'm just going to do this for all of them. And I'm doing it even for my gets. Oops, I already have part of that there. I'm just not requiring it yet. So let me just replace it. There we go. And that is it. Now we're down to the authorizer function. So I think I have everything. Just save that. And now I'm going to build. And then we'll deploy. and we'll take a look at what it looks like in the console, and then we'll test it.
Lia, a question has just come in from Anchor. Anchor, thanks for joining us. Lambda authorizer is Boolean type or returns an IAM policy. Which is good to use?
Okay, so the Boolean, that's only going to be for HTTP APIs, and that's going to be very simple. And this is basically when the request comes in, it's a yes or a no. So there's no fine-grained access control there. So if your use case is just like where you only need just like a simple yes or no, then and you're using HTTP APIs, that can be an option for you. If it's a more critical application and you need fine-grained access control, then you're going to want to produce an IAM policy. So Dogfinder, if I was using HTTP API, I could probably just return like authorized or not authorized, but in this case, we are going to return a policy. Okay, so the build should be done. So let me go and deploy.
But also know you do need to sort of think about some of your cache when you are caching. Think of some of your caching mechanisms, because you could have multiple APIs which have different authorization requirements, and you don't want to be caching the same results from a GET request that then goes through for a PUT request in another part of your application. So I know some of the headers you can amend or do something like that to say maybe have different authorizers, different authorized caching per method or something like that. So I know that is something also to consider.
Yeah, definitely. And I've come across this personally before, and also with other customers, where like you really do need to think about upfront in your authorizer, like when the request comes in, if you are caching that for like 5 minutes, and let's say like a GET request comes in and you're like, yes, this GET request is authorized, I'm going to allow GETs for, we'll say, all of my paths. But then the PUT request comes in and we cached it, and we didn't actually consider that this next request could have been a PUT, they're going to get denied because we're caching that. So make sure that you include all the methods and paths.
Yeah. And it's also, I suppose, not just being denied, but your GET request could be cached, and then your following request could land up being a PUT or a write to a database, for example. But because your previous access was cached and you don't have sort of further defense in depth, you could land up having, in a scenario where your customers or something are able to write things to your database when you were only intending with them to read.
Yeah, definitely. All right, look, we have our Lambda token authorizer, and we are also requiring an authorization header. So let's go back to Postman and test this really quick. So remember, I'm using no auth, and this is just a GET request, and I'm unauthorized. So real quick, let me just go grab a token. I'll take an ID token. And it's an old one. And just so you can see, Postman just automatically adds the authorization header in there. I could have done that manually, but they make this nice. I'm going to send that. Whoops. Oh, wait, hold on. Now I'm getting a 500. No. Okay.
This is where we're doing live demos.
Yeah, for real. So I could go in here on the GET and.
So this is probably an issue either with the authorizer Lambda function or the
most
GET
likely it is.
Lambda
Yeah,
function.
most likely it's the authorizer and maybe not able to parse that token. But for the sake of time, debug time, something with Lambda auth. Yes, most likely is my authorizer, which I can really quickly. Let me go find my authorizer, get the name of it, and we can go to Lambda really fast and go look at the logs.
At least the Lambda
Error
function
decoding.
has fired. So there you go. Error decoding the headers.
Yeah, though. You know, the funny thing is like I tried this 3 times this morning,
Of course.
adding this, and it worked fine. So, 2.
Biswajit, I think you need to remove the slash at the end of the URL. That could be that is a suggestion at least. But then
I don't think so.
No, because your authorizer would have, your authorizer would wouldn't have fired then.
Yeah. Either way, I'm going to move on. So, because I don't know if it's going to be super interesting for me to debug all of this.
Yeah, if we had another hour, we could go into the whole debugging, but we'll just pretend that it all worked and the custom authorizer did its thing.
So, to take a step back on the custom authorizer though, so start with the blueprint that we have here. Next, I mean, you may already know the custom business logic and everything that you need to add there. You may already have libraries in mind, but a common question I get is, okay, so what libraries should I even be using to validate my tokens? And so what I recommend is using jwt.io. They have some libraries here, and you can filter by whatever language you want. I'm actually using this one right here, but this is going to be a great way to go find the right library for you. Also, if you do need to debug your tokens, in this case, I don't think it's a token issue per se. Oh my gosh, I do see my issue. I didn't copy my full token. Dang it. Let me try that again.
That's the whole wall of text. Not so easy to.
Yeah, I missed the first line. So this is, so let me pull up. All right, let me go back to. Copy and paste errors. Yes.
Good troubleshooting.
Oh, yeah, troubleshooting. And it's like, I just missed a line in my copy and paste. So anyway, there we have it. We are passing the authorization header and we are getting a response back. And also if you ever do need to troubleshoot or want to decode a token, you can use this resource here. I want to talk about a few more things. So let's move on from here. So we've already done this part. We actually invoked the Lambda function. It worked great. We got to see Xena. Okay, so a little bit of the Lambda authorization side. I'm assuming most of the people, if you're here, you've deployed a serverless application, so you're probably familiar with like a function policy versus execution role. So function policy is like a resource policy in that it defines like who can invoke your function. So in our case, API gateway, where the execution role is what Lambda assumes, and it's the permissions for what your Lambda function can do. So in my case, it's going to be like write to DynamoDB or read from DynamoDB. So on the function role, this is the API call. It's add permission, and you can specify API gateway. And it gives you a policy like this. But you should note that if you're using SAM, which we highly suggest you use, or the management console, it'll create this automatically for you. And it does that like when in my template, when I'm specifying that the event is API gateway, it will take care of that for me. Okay. And so on the execution role, this is a really important topic. So this is the IAM role that's assumed by the Lambda service. And in our case, our Lambda function needs to like read and write to the DynamoDB, so put item, update item, etc. And we want to follow the principle of least privilege here. It is pretty easy just to go like wildcard and say Dynamo needs like all the permissions, but that's obviously not the most secure. And then like the beauty of Lambda is that you can break it up between all your get and posts and do individual policies for each of those. So you might be thinking like, yeah, I get that concept of least privilege, but I struggle with IAM policies. And I'm definitely guilty of like, why isn't this working? Let's just star, just to get it working. And of course, we always go back and fix those permissions later, right?
Always.
Always, yeah. We don't just like forget about it and move on with our lives. But SAM makes this a lot easier. They have a list of policy templates that allow you to scope the permissions to the resources that are used by your application. So here's an example of DynamoDB write. So it gives write-only permissions to a specific DynamoDB table. So what this means is like these two lines, and you might have noticed this earlier in my template, turns into this policy. So make sure you're aware that these exist. And really quickly, I can just show you in my template. I'm going to scroll back up to the top. I'm sorry if I'm making anyone sick. Okay, so here's my get all dogs function. And we can see here, I actually have a DynamoDB CRUD policy. And so this is going to give me permissions to create, read, update, delete for my get function. And so this is actually overly permissive. So I could change this because we also have a DynamoDB read policy. And you can find these in our documentation as well. I think I have that up.
Yeah, I'm gonna put the link in the chat. So the SAM's policy templates, I think they're like more than 75 or whatever. And now just there's absolutely no reason not to use them. They're just so simple. As you saw, Lia, they're just literally changing CRUD to read. You don't have to craft your own IAM policy, and you're done. So yeah, super powerful.
Yeah. So I'll save that in a moment. I'll show you that that actually works. Hopefully, unless I made a typo, but that should be called DynamoDB read policy. And while that goes, I want to show you one more piece, because often I find that I talk to developers and they love this aspect, but then also in my same audience is I have people more on the platform teams, and they're like, that's cool. I'll tell my developers about this, but like, how do I ensure my developers are doing the right thing? And because sometimes developers do this, like I just admitted to the entire world on the internet, that sometimes I star everything when stuff isn't working and I can't figure it out. So I want to talk a little bit about permissions boundaries. So this is how, if you are more on the administrator side, how to enforce least privilege for your developers. So we have IAM permissions policies. We already talked about that. They're defined by the developer. Me as a developer, I'm given permissions to create IAM roles and policies, etc. The administrator, so whoever's on the platform team or security team, can create something called a permissions boundary. And so this is just another policy. And the two intersect, and the effective permissions for the IAM principles are applied. So let's talk about this a little bit more. It's really about controlling the max permissions a developer can grant. So we have the permissions boundaries, and we have the policy that I just created as a developer, and the permissions boundaries is just applying like a max boundary. So it's attached to users, roles, groups. It defines the max permissions. It doesn't limit permissions on resource policies, and it doesn't grant permissions. So to give you kind of a scenario, we have Sam. Sam's a developer. Sam has permission to create policies and create roles. We, as administrators, are going to require that a permissions boundary is attached to the role. And then the effective permission of that role is the intersection of the two policies. So if Sam just does star, 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 and we have a permissions boundary that has less permissions, it's going to essentially, you can think of it like capping the amount of permissions.
So would examples of this be for, something like your central security / governance team can say that every API gateway, every Lambda function behind API gateway has to have an authorizer, or has to have some authorization mechanism? or a Lambda function
Um,
has to be part of a VPC or not part of a VPC, or where am I mixing these up?
Yeah, so you're thinking of more of just conditions, and that is something that exists. You can do that with API Gateway. There was a couple years ago now a release that allowed for that. This is specific to what you as a developer can apply to a application essentially. So this is an example of a very simplified permissions boundary here. So we're saying that you can do anything on any resource as long as that resource is a Lambda function that starts with dogs or a DynamoDB table that starts with dogs. So if I start everything, and then I'm reducing the risk of like I can't make networking changes, that sort of thing. Of course, here I'm also allowing logs to be created and put so that like my serverless application can log. So
that distinction is, this is to control the permissions boundary of what developers can do rather than maybe what the application can do. So this developer can only work within Lambda functions named dogs. So if there were a whole separate microservice for cats, this developer wouldn't be able to do anything with that.
Actually, it's the other way around. It's more, so I'm creating let's say I create as a developer a policy that's going to be attached to role, and it's like an admin policy. Well, that's not great. So when we apply this permissions boundary, this is enforcing the fact that I can, it's the intersection of the two applied, and this is basically putting a cap. So I can do anything that *** still applies, but as long as that resource is like Lambda starts with dogs, Dynamo starts with dogs. So it's not on me as a developer myself, it's on what I'm applying this to. So I think this might, in my next couple of slides, I think that might show a little bit better, because we enforce permissions boundaries by making it a condition, which, Julian, that's what you were talking about before,
yeah.
The condition that is applied to the user. So this bottom part here, me as a user, a part of my policy says I can create roles as long as this permissions boundary here is attached. So what's different is I create my role and I attach a permissions boundary. That permissions boundary is the new and different thing. I still create my normal identity-based policy, and I still attach that policy to my role. And what looks different in my SAM template, like I'm using my DynamoDB CRUD policy again, but I'm also attaching that permissions boundary. So if I was going to go do my SAM build and then SAM deploy, and I didn't have the permissions boundary attached, when I have this policy applied, it would fail, if that makes sense. So if you're on the administrator side, this is something you would want to consider. And then I'm going to wrap up the offsite since we only have a few minutes left. You may already be familiar with like Secrets Manager, but in terms of like handling your API keys and other secrets, make sure you're using a managed service like Secrets Manager. And Secrets Manager can also help rotate these, and it's secured with IAM permissions as well. So quick recap on that. Make sure you're using the right authorizer for your API gateway. I gave you some resources on how to get started with the Lambda authorizers, but if you only need something simple, you could use the native JWT authorizers, or if you're using Cognito, you can use the native Cognito integration. Use SAM templates to follow the least privilege model, and then store your secrets using things like Secrets Manager and so on. I skipped RDS proxy, but if you have a relational database, make sure you're using RDS proxy, because that actually supports IAM authentication, which is going to be better than password auth. So I'm going to skip towards the end, because I want to make sure you can see everywhere that you can apply security in your architecture. So if we're talking about from the infrastructure standpoint, we can use Shield for DDoS protection, as well as CloudFront. It can integrate WAF with both CloudFront and API Gateway. So WAF helps us with things like cross-site scripting and SQL injection, and the other like OWASP top 10 risks that you have identified. We can do authorization at API gateway. We can configure cores. We can do some basic validation. So you can do basic validation with API gateway, as well as some validation that includes like business logic in your code within Lambda. You can enable throttling. The type of endpoint you use in API gateway is also part of how you should think about security. You can specify resource policies. And if you do use cache, you can also encrypt your cache in API gateway. On the Lambda function side, a lot of this has to do with just your code and just following secure coding practices. And if you want to learn more on that, OWASP is a great resource there. We also covered the policies of function policies and execution roles. You want to make sure that you minimize your dependencies and do vulnerability scanning, because sometimes dependencies have vulnerabilities. There was moderately big one recently that we can all probably think about or remember. And then, of course, we need to be thinking about how we encrypt all of our data at rest. So we can do this using things like KMS. There's also, if you want to do it client side, we have libraries for that. And on that last bottom piece there, observability and logging is super important, not just for like the availability of your application, but also for security. So implementing logs, like with API Gateway, we can do our access logs, but you can do logging at every layer in the stack. And so that can all go to CloudWatch. Obviously, you're probably familiar with CloudTrail, recording all the API calls in your account, as well as config to doing recording any configuration changes, and then creating rules to ensure that your configuration stays within compliance for your organization. And X-Ray gives you the overall observability. So that's my really fast summary there. I wish we could have gone more detail on each of this, but security is a very big topic.
Well, Lia, you've certainly brought it to life in an excellent way. There are just two links I'm going to stick in. One is there was a question earlier about, are there ways that you can statically analyze code? And there's Code Guru, that's one of the things, but there's another one people may not be aware of, something called serverless rules. And this is just a GitHub repo that you can use to enforce some best practices, not necessarily only security ones, but you could have some security things in that. So that's another thing with that question. And then obviously there's loads more to do with security. And Lia did literally one of, I think, the best serverless sessions at reInvent 2021, all about serverless security best practices. So part of what Lia's been through today is in that talk, but a lot more. And as you saw in the summary slide, there are a lot of places you can do security. So it's really a great story about doing security in depth with lots of different options. Lia, I super appreciate you being on Serverless Office Hours today. Thanks so much for all your insights and the brilliant stuff you bring to it. Thank you so much. Up next week, we've got Lambda, and we've got some new toys to hopefully show off. So that'll be super cool when that's coming out, hopefully before next week. And of course, if you're building infrastructure as code using CDK and now Terraform, as well as with SAM, look at the serverless patterns collection. This has got a whole bunch of infrastructure as code tools and general serverless stuff. Look on serverlessland.com. Blogs, videos, learning paths, anything to do with serverless on AWS. Lia, thanks so much for joining Serverless Office Hours today. It was brilliant to have you. And yeah, we hopefully can have you on another time to talking even more about security.
Thank you.
Cheers. Enjoy the rest of your day. Thank you.